Okay, so your formula sheet for this test has these formulas on them, but you do still need to know how to manipulate these things algebraically. But we worked some examples last time, and now we're going to verify an identity. So definitely on this page, there's really not enough room, but I fit it in here, but let's try it. I'm going to write something above, write the identities. Here's the identities we're going to use for the next two. Yeah, you understand this stuff?
Yeah, it's more algebraic. You just plug it in.
Yeah. So if you struggle with algebra, you're going to have trouble with this section. But
when I was reading 5.2, then I was like, oh, this is actually pretty easy once you get over all the weird symbols and everything.
Right. So sine theta. I believe I have the formula sheet posted that you can see which ones are on the formula sheet and which aren't. But okay, so verify the identity. Sine of 3 theta equals this. So I started with the left side, even though it's not as complicated. I rewrote sine of 3 theta as sine of 2 theta plus theta. Okay? Now, so that equals, so I'm using this formula up here. My alpha is going to be 2 theta and my beta is theta. So just going to replace right here. Sine, I'm just going to write sine, leave a blank, cosine, blank, plus cosine, blank, sine, blank. So the first angle goes here, second angle goes here, first angle here, second angle here. All right. So now what are we going to do? Well, we're going to use an identity for sine 2 theta, the double angle formula that we have on the first page. And that I'll write up here is sine of 2 theta equals 2 sine theta cosine theta. Okay, so we're going to replace sine 2 theta with that, and then we have a double angle for cosine formula. Cosine of 2 theta equals all of these things. So we're going to pick the best one to use. Or equals 2 cosine squared theta minus 1, or it equals 1 minus 2 sine squared theta. So, replace sine 2 theta with this. Equals 2 sine theta cosine theta. And then bring down the cosine theta plus. And I found that the best one to use was this. Why? Well, we're going to end up with a cosine squared here, and we want a sine squared here. Is that why? I imagine you could use any of them and still manipulate it and work it out. 1 minus 2. Oh, I know why I chose that one. I'll explain that. It's because we got some signs here. We want to make this side equal to that. We want to get everything in terms of sine, so choose the one that makes cosine in terms of sine. That's why I'm choosing that one. So I'm choosing this one for cosine 2 theta. So it's 1 minus 2 sine squared theta times sine theta. All right, now I'm going to distribute and write this as cosine squared. So it equals 2 sine squared sine theta cosine squared theta plus sine theta distributing minus 2 sine cubed theta. All right, we want everything in terms of sine, so we're going to replace cosine squared with 1 minus, wait a minute, what did I do here? Cosine 2 theta, oh, what's cosine squared does not equal this. This is cosine 2 theta. Cosine squared plus sine squared. These are all the identities over here that I'm using. Equals 1, so I'm going to replace cosine squared theta with, I'm going to solve this for cosine squared, subtract your sine squared. Equals 2 times sine theta times 1 minus sine squared theta plus sine theta minus 2 sine cubed theta. And then we're going to distribute this, and then we'll combine our like terms. So now I've got to continue over here. 2 sine theta minus 2 sine cubed theta plus sine theta minus 2 sine cubed theta. Combine our like terms into understood 1. So that's 3 sine theta minus 4 sine cubed theta. And so it's verified. All right, does anybody else come in? Jacob? Okay, so everybody knows, everybody's here that's come today, that there's test corrections for the last page if you miss points. Not the whole last page, just 6 problems. If you miss points on those problems, you can get some points back. If you do those, it's due by Thursday in Shelby. Work it.
What numbers were those?
What numbers are those?
7 through 9.
There's detailed instructions in Shelby. Go look at that. That's going to help you more than just what numbers are. Okay? No, it was numbers 7 through 9 and 12 through 14.
Yeah.
Yeah. Oh, did you say 12?
Yeah.
All right. Okay. So I've told you exactly in Shelby how you were supposed to work those, so if you didn't understand it, you thought you could just cancel, then you can look back at the 4-7 worksheet we did, look back at the 4-7 notes, and I may give more credit than the half on the first 3. Okay. I might, okay. So do it. Sometimes I do things like that, do it. Not going to take very long. And I showed some of the answers up here in a second. All right. Any questions about that? Now the next one is exactly the same. So I really don't want to spend the time to go through it all. This number 8 works exactly the same as the one we did, except this time we want everything in terms of cosine. We're rewriting cosine as 2 theta plus theta. And I don't feel it's worth the time for me to work this one all the way through again. It's exactly like what we just did, except you want to use the thing, solve for cosine. So choose the things that, for cosine 2 theta, we chose this one because we want to have everything in terms of cosine. And sine squared theta will be 1 minus cosine squared theta. So, does that make sense? What? No? Do you want me to work it?
Yes.
Yes? Okay, I will work it then. Sorry, I just thought it was the same. All right, cosine of 3 theta. We're starting with the left side. We want to make it look like the right. That's how we verify identities. We don't change both sides at the same time. Okay, so just change the left side here. Can be rewritten as cosine of 2 theta plus theta. And now we're going to use this identity right up here. Cosine, and it's on your formula sheet. So that equals cosine of 2 theta cosine of theta minus sine of 2 theta sine theta. Now we're going to replace cosine 2 theta with the identity that has cosine squared in it. So this time we want to pick, for cosine 2 theta, we want to pick this one. And for, sine 2 theta, we're going to use this again. Oh, you can't see it. There we go. So cosine 2 theta replaced with 2 cosine squared theta minus 1. Sine 2 theta is replaced with 2 sine theta cosine theta times sine theta. We're going to distribute the cosine, so we get 2 cosine cubed theta minus cosine theta minus, and then we'll write this as 2 sine squared theta cosine theta. Now we want to replace sine squared theta with something in terms of cosine. So we take this identity up here, cosine squared theta plus sine squared theta equals 1. And I'll write it over here. cosine squared theta plus sine squared theta equals 1. We're going to replace sine squared theta with, subtract the cosine. Sine squared theta equals 1 minus cosine squared. We're just trying to get everything in terms of cosine because our right side has all cosines. Equals 2 cosine cubed theta minus cosine theta minus 2 times 1 minus cosine squared theta, and then that's times cosine theta. So I probably should have written the cosine first, but we're going to take 2 times cosine and distribute it. 2 cosine, we have everything in terms of cosine. Distribute the 2 and distribute the cosine. That's 2 cosine theta. And then distribute the minus 2, you get positive 2 cosine squared theta and multiply by cosine. You had to distribute the minus 2 and then also multiply by cosine, distribute that. So my filled-in notes, I wrote this first, that would be better. You guys follow that step? Okay. And then we combine our like terms. There's an understood 1 here. So that's 4 cosine cubed theta minus 3 cosine theta. And that's verified. We got the same thing. So we started with the left side and we got the right side with manipulations of identities, trig identities. All right, then we have power reducing formulas. In the book, we'll show you how they derived all these formulas from the previous ones. I'm not going to go through all that. So sine squared theta equals 1 minus cosine 2 theta divided by 2. Cosine squared theta, these are, so if you want to get rid of some powers, squared, this is 2, it's not a squared, it's 2 times theta. That's inside the cosine. Cosine squared theta is 1 plus cosine 2 theta divided by 2. And tangent squared theta is sine squared theta over cosine squared theta. The 2's cancel when you do that. You're left with 1 minus cosine 2 theta over 1 plus cosine theta. Okay, so I'm not sure, I have an extra, cosine squared 2. Oh, okay. Okay, so these blanks never have enough room. Even. So we're going to use these identities to write an equivalent expression for sine to the fourth x that does not contain powers of trig functions greater than 1. So, and you know to manipulate things that you have to have the same angles. Sine squared theta plus cosine squared theta equals 1, but sine squared alpha plus cosine squared beta does not equal 1. You can't have different angles. So that's why we have these. You've got to get the same angle to use these identities. So we're going to start sine to the fourth of x can be rewritten as sine squared of x squared. And sine squared of x is this, so we're going to replace so we're going to put in 1 minus cosine 2 theta, and that's squared, and the denominator is squared. When we have the squared here, when you square a fraction, you can square the numerator separately and the denominator separately. Okay, and then we're going to FOIL. Oh, I don't know. I have thetas and x's mixed. I'm sorry. This is an x. We're using x now, so it doesn't matter as long as we keep it consistent. If they were all thetas, it'd be fine. All x's would be fine. But now we're going to FOIL this. So, I can write it up here. 1 minus cosine 2x times 1 minus cosine 2x. So we're going to FOIL that. 1 times 1 is 1. The outer term is minus cosine 2x. The inner term is minus cosine 2x. We get minus 2 cosine 2x. I skipped a step. It's the outer and inner terms added together. Do this. And then minus cosine 2x times minus cosine 2x is plus cosine squared 2x. And of course 2 squared is 4. Did I lose you when I skipped that one step? Follow that. We were doing the outer and inner terms are minus cosine 2x minus the inner term cosine 2x. I got the first and the last terms here, the outer and the inner combined. There's an understood 1 to minus 2 cosine 2x. Outer and inner. Okay, now, and I'm going to do things off to the side, up in a different area to leave room for my work here. So cosine squared 2x we can figure out what cosine squared 2x is. Cosine, that's why it's written up here. Cosine squared of 2x. We're going to let 2x equals theta. So we have theta here now, so 2x. and then we're gonna replace back into it. So cosine squared theta equals 1 plus cosine 2 theta over 2. Now we're going to replace back for 2x. Theta equals 2x. So we're going to substitute for theta 2x. 1 plus cosine, 2 times 2x over 2 is 1 plus cosine 4x over 2. Sorry about that. So, clear as mud, right? No, we're using this formula for this, and if you could do it directly without this substitution, your 2x is going to be your theta here. So you have to you just put 2x here. If you can do that, you don't have to write all these steps out. You see that? Okay? So now I'm going to go ahead and divide each factor by 4. So this is going to be equal to 1/4 minus, and 2 over 4 is a half. 1/2 cosine 2x. Divide that by 4. Divide this one by 4. So I'm going to, instead of dividing by 4, I'm going to write it as plus 1/4. And we're replacing cosine squared 2x with this stuff. 1 plus cosine 4x over 2. All right, then we're going to multiply this. 4 times 2 is 8, and we have it. Let's see. We're going to write this as 1/8 in front of there. One-4 minus 1/2 cosine 2x plus a half times a 4th is an 1/8. We just brought it out front. Now we have, they want it, and if they want terms, I'm gonna distribute that, get terms. 1/4 minus 1/2 cosine 2x plus 1/8, distribute the 1/8, plus 1/8 cosine 4x. And the last step, combine your fractions. 1/4 is 2/8, so that's 2/8 plus 1/8 is 3/8. 3/8 minus a half cosine 2x plus an 1/8 cosine 4x. Okay. That makes sense? Yes. All right. So the other one works the same way, and the other example again, rewrite this as cosine squared x squared, and that equals, we're going to replace cosine squared x with 1 plus cosine 2x over 2. X, we got an x instead of a theta. Just replace there. Okay? And that has to be squared. So when you square this, you're gonna get 1 plus 2 times the middle term plus the last term is cosine squared 2x. When you square the denominator, you're going to get 4. Then you're going to separate the 4 and rewrite cosine squared 2x as 1 plus cosine 4x over 2. What you're doing is plugging 2x into this formula. Your theta is 2x, you get 4x here. It's the only difference. Okay, so separate it 1/4 plus 2 over 4 is a half cosine 2x plus a 4th times 1 plus cosine 4x over 2. This is 1/8. So you get 1/8 plus 1/8 cosine 4x cosine 2x plus a 4th. And just combine a 4th plus an 8th. And the only difference is one sign. We get 3/8 plus a half cosine 2x plus an 8th cosine 4x. Question? Okay. Got all that? Okay, so the next thing is half angle formulas. And they say they're plus or minus 1 minus cosine alpha divided by 2. And cosine alpha over 2 is plus or minus the square root of 1 plus cosine alpha over 2. Tangent is plus or minus the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. Okay, so what does this plus or minus sign? This does not mean it can be two signs. It means you have to pick the right sign by the quadrant it's in. You have to pick the right side by the quadrant that alpha over 2 is in. Okay, so we had a smart trig class. In quadrant 1, all are positive. In quadrant 2, so this was all positive. This quadrant 2 was sine and 1 over sine, which is cosecant, positive. This is tangent and 1 over tangent, positive. And this is cosine and 1 over cosine, secant positive. So, reminder of that, we have to use that. We're going to now get into the application of this section. So, another thing I wrote on my paper is it's a common mistake. This is from your book. Your book has these common mistakes. It's a very good book. The sign of a half angle is not, a common mistake is that it's equal, okay? The half of sine of the angle. So that's not correct. This is cosine of theta over 2. This is a common mistake to think that that equals half of cosine theta. Or tangent of theta over 2 equals half of tangent theta. Don't do this. This is a common mistake and it's not correct. It's supposed to be these pictures. Graph. Okay, so now we're going to use the half angle formulas to find an exact value. So use use that fact that cosine of 210 degrees is minus square root of 3 over 2 to find the exact value of cosine 105. So this is quadrant 210 is in quadrant 3. In quadrant 3, cosine is negative. .105 is in quadrant 2. The cosine there is also negative. You have to notice that. Okay, so we're going to use the half angle formula for cosine. We're going to pick the minus sign because 210 has a negative cosine. So cosine of 210 degrees equals, oh, no, wait a minute. That's not what we wanted. Cosine of 100, we're trying to find, we're using this cosine, this given value to find the half angle, which is not as easy to find. We're finding the exact value for that. Cosine of 105 degrees. So our 105 is our alpha over 2. 210 is our alpha. So cosine of alpha over 2 equals, we pick the minus sign because alpha over 2 is negative. Sorry about that. Cosine of alpha over 2 is negative. That's in quadrant 2. Square root of 1 plus cosine of 210 divided by 2. Square root of 1 minus, and they gave it to us, square root of 3 over 2 divided by 2. Now we got to simplify this. We have a fraction within a fraction inside the square root. We got to simplify that. So we got to the easiest way, I think, is to multiply by 2 over 2. You're going to be distributing that. Equals the opposite of, I'm distributing the 2. I get 2 and minus square root of 3 over 4. right, that's all under a square root. Now we can just take the square root of the numerator and the square root of the denominator separately. And that's square root of 4 is 2. And so this is the exact answer. And then if you want to put it, you put it in your calculator. If I ask for approximate answer, or maybe MATLAB does, negative second square root of 2 minus second square root of 3. Now, I have to close both parentheses because I'm not under the square root anymore when I divide by 2. Divided by 2. So, just, did I do it wrong? Let's see if I did the parentheses. Oh no, that's right. I was looking at the next one. Okay, negative 2.2588, 4 places. Okay. All right, so if I ask you this question on the test, you're going to have to do it this way. If I ask, I'll tell you to use what formula to use, you'll have to do it that way. There's many ways to find cosine of 105 degrees, the exact value. This is the exact value, this is the approximate. Find the exact value of 112.5. Well, this is half of 225 degrees. So my alpha over 2 is 112.5, and my alpha is 225 degrees. So this is 112 degrees, is between 90 and 180, so it's in quadrant 2. Cosine negative. All right, so find the exact value, so we're going to do cosine of 112.5 degrees equals negative, pick the negative, square root of 1 plus cosine of the double angle, twice that, 225, divided by 2. That's the formula.
Where did you get the 225?
Well, I took 112.5 and multiplied by 2. And 225 is one of those angles that we could find very easily. So I even drew a picture here. Here's the unit circle. This is 45, 90, 135, 180, and 270. 225 is right here. And that has coordinates of negative square root of 2 over 2, comma, negative square root of 2 over 2. So we're using the half angle formulas above. So we have, if you take 2 times the 112.5, we get an angle that we have on our unit circle. Okay. And so the cosine of 225 is minus square root of 2 over 2. 1 plus the square root of 2 over 2 divided by 2. Simplify that. You can't leave it like that. is, well, let's put it up here. Negative square root of 2 plus the square root of 2 over 4, and then we separate it, it does equal negative square root of 2 plus square root of 2, all divided by 4. No, 2. We took the square root. We put that in our calculator. I forgot how long this was. It's a huge problem, but negative second square root of 2 plus second square root of 2. Close that parenthesis, and you have to close the other square root because my 2 on the denominator is not under the square root. Negative, wait a minute, did I do that wrong? 2 plus the square root of 2 under, divided by 2, all divided by 2.
So square root of negative 2.
What? Oh, there's a minus sign. See, cosine of 225, I forgot, is negative. So I have a sign error here. This should be negative, negative, negative. Okay, so I have it right there, negative. So we do have to watch the signs, okay? So we got to change the sign. Right here, minus sign, subtraction. And that's the correct answer. And this is the exact answer. And the approximate answer is approximately negative 0.3827. Okay? All right, and then we're going to use a figure to find the exact value of the following trig function. So here's theta. This is a right angle. So sine, we don't even know what the degree of theta is, but we don't need it. Sine of theta divided by 2 is going to be we're just assuming these are all positive numbers. You don't see any negative signs here, so these are all positive. So sine of half angle, we're going to use the plus sign. Square root of 1 minus cosine theta over 2. I just copied that from the formula above. Well, cosine theta, according to the picture, is 15 over 25. Divide by 5 is 3/5. So we got to replace cosine theta in here with 3/5. 1 minus 3/5 divided by 2. You can't leave a fraction within a fraction. And we don't want to leave a radical in the denominator either, square root. So what I did on this one, I went ahead and subtracted 1 minus 3/5 is 2/5. And this is divided by 2 over 1. You can't cancel the 2's. Well, you could, but let's actually flip it and show you. Equals 2/5 times 1/2 and you get 1 over the square root of 5. Well, it's the square root of, just multiply by square root of 5 over square root of 5. Square root of 5 over 5. So this is your answer. Okay, so you need to remember, you're going to be expected to show your work out by hand. You need to remember these rules for fractions and square roots.
What will the formula sheet contain?
It's posted.
Okay.
I don't have it with me, I don't think.
That's on Shelby or Northeast?
Probably both.
Okay.
I don't know. So, half angle formulas for tangent is 1 minus cosine alpha divided by sine alpha, and either one, and sine alpha over 1 plus cosine alpha. Half angle formulas for tangent. So here's verify this identity that tangent of alpha over 2 equals secant of alpha divided by cosecant. No, I'll just write it like that. Secant. It was secant times cosecant plus cosecant. Okay, so I'm going to start with the right side and try to show that it's that. So I'm going to try to get something like this on the right side because this equals that. No, I guess, no, it didn't work that way. What I did first, I'm starting with secant alpha over secant alpha, cosecant alpha, plus cosecant alpha. I just rewrote everything in terms of sine and cosine. This is 1. So you can do cosine alpha. 1 over secant is 1 over cosine. Secant is 1 over cosine. Cosecant is 1 over sine. 1 over sine. Okay. What's the common denominator that you can multiply both parts of the fraction by? You get rid of all these denominators. This times this. So we're multiplying by sine alpha times cosine alpha. When you multiply a fraction by something over itself, it just changes the look, not what it means. So and there's probably more ways to do this. But I did this, multiply that times that. When you multiply this times that, the cosines cancel. You're left with sine alpha in the numerator. When you multiply 1 over cosine alpha times sine alpha times this, you get 1, not 0. These things cancel for that one. But on this one, you have the sines cancel, but the cosine's there, so plus cosine alpha. If you need to write out more steps there to follow it, but I distributed. You could write those out. So now I'm actually just I'm gonna use the fact that sine alpha Sine of alpha is so we're using the previous formula. Okay. Oh, okay. I'm going to use this formula. I'll write it over here. From the first page, we've got sine of 2 theta equals 2 sine theta cosine theta. And if we let alpha equal 2 theta, then that's what I'm showing off to the side here. If alpha is 2 theta, then we have sine sine of alpha equals 2 sine alpha over 2. If alpha is 2 theta, then divide by 2, theta equals alpha over 2. And cosine of alpha over 2. So, instead of, and I'm going to do the same thing with the cosine formula. We know that cosine 2 theta equals, and we want everything, I'm going to use the 2 cosine squared theta minus 1. I picked that one. Again, alpha is 2 theta, so cosine of alpha is 2 cosine squared alpha over 2 minus 1. Theta was that. Okay. All right. We're replacing all of that. Sine alpha is, sorry, 2 sine alpha over 2 cosine alpha over 2. Sine alpha was that. We're 1 plus 2 cosine squared alpha over 2 minus 1. The 1's cancel. Now we're replacing 2. I have to replace the cosine squared alpha over 2 equals 1 minus sine squared alpha over 2. The identity, cosine squared theta plus sine squared theta equals 1. So it's true, sine squared alpha over 2 plus sine squared. That, I'm replacing that. So I have 2 sine alpha over 2 cosine alpha over 2 divided by 2 times, wait a minute, I'm not using that. What? I'm not sure what I use. Cosine squared. I've got it written down, but I didn't write down my identity that I used. How did I get cosine squared? We're almost done. We'll just quit after this. I think you've had enough after this. Cosine squared alpha over 2. Cosine squared, what did I use? I can get back to you on it if you,
Use 2
did I use cosine?
alpha over 2.
What? I have, what?
2 cosine alpha over 2 cosine alpha.
On my filled-in notes, I have 2 times cosine squared alpha over 2 equals cosine alpha over 2 cosine. Oh, I just separated it.
Yeah.
Oh, it's so easy. Okay, I just separated the squared, guys. No wonder I didn't write that down. Okay, cosine alpha over 2 cosine alpha over 2. And so this is tangent of alpha over 2. The 2 cancel. So we didn't even use the identities up there for the half angle. We probably could have. We probably could have used those identities somehow. Oh, I don't know. We could have, if we used those identities up above, we could have stopped right at this step. It says it's equal from the identity above. So, all right, but that's more showing you how complicated that could be. Have a good day. See you Thursday. We will do 5-4, 5-5 on Thursday.
Because we have the test corrections, are you still planning to give a quiz that day?
No. No, the test corrections were instead of a quiz. I didn't think we had class time today.
It's on the list.